Okay, and welcome back to the bench. Fred B. Radio here. If you remember, if you follow my videos, a couple videos ago I did an unboxing. One of the things that I unboxed was a Triplett 310 pocket multimeter, a VOM. Now, before I get started, I just want you to understand that I didn't get taken. I knew exactly what I was buying. I paid 99 cents for this meter, 99 cents. So I knew getting off to the start that there was something definitely wrong with it. Otherwise, nobody would have been selling it for that price. That being said, in the pictures, there was even in a picture that said, meter returned unrepaired. There was a label on it. I knew something was wrong. So when I unboxed it, it was kind of crappy looking. It had gunk all over it. That I eventually got cleaned up. The leads were rubber leads, and they were all dried and cracking, so I had to replace the leads. Now, this is not going to be my primary meter. I'm going to go into a few things that I've done, and I'm going to show you some still pictures because I didn't take videos of everything. It was a little frustration level there going. I'm not a meter repair guy, but a meter is a piece of electronic equipment that, hey, if you restore something, you should be able to restore that as well. So that's the road that I took. And again, first things first, go online, see if you can find some literature, some schematics, so you have a clue as to what's going on inside the meter with the switches and everything. So what I'm going to do is I'm going to show you some still pictures of the inside of the meter of what I found. Well, I plugged it in, I put the probes in it. It didn't read anything. AC, DC, ohms, nothing. Okay, so I knew there was something wrong inside. With that, I'm going to cut in some still pictures here and then get back to you showing you the actual meter. Okay, this is the completed board. This is the switch, and here's what the board looked like when I first got it. Okay, so here is the meter finished. Like I said, I didn't do a lot of recording on this. I wasn't even sure if I was ever going to get it working, but it is working. I'm just going to go over real quick. You saw the pictures from inside. There are traces that were blown off of the circuit board. I don't know what they did, but obviously they shorted it to the wrong stuff. And inside you can see there's missing traces. And in the other video you can see that where I actually repaired the traces to help me get it working. So once I did that, actually before I did that, one of the things I did was I wanted to test the meter. When I saw the board in that condition, I wanted to test the meter. Now it's a 50 microamp movement in the meter. So I set up my power supply here, 10 volts, 10 volt DC with, I think it was a 200K resistor, gave me 50 microamps, and the meter was working. It's off a little bit. Yeah, it took a hit, but it's still working. There's probably some shorted turns or something in there. So, but it's working. This, again, was just going to be a backup meter for having in the car. All right, so the meter itself is functioning. But then I got it working, but the calibration was way off on it. Obviously, the meter took a hit, and I had to compensate for that. So you can see over here, here's my pile of resistors. Yes, these are 5% resistors. You're supposed to have 1%, and in one position is supposed to be 0.5%. The meter calibration resistor should be 0.5%. I measured all the resistances, and I also found a blown resistor for the 600 milliamp range. Still haven't replaced that yet, and I found one diode was bad. Again, interesting, when I checked the AC, I had it on 120 volts, and I was getting pretty close to 60 volts, which is half of what I was feeding into it, which pointed me in the direction of the diode bridge. And of course, there was one bad one. Replaced that, got the AC working. I decided, you can see these two resistors here. These were actually for the 600 volt DC and 600 volt AC ranges, which I have no intentions of using this at that. So I took them out, I put plugs in, I took the jacks out, okay? And I put plugs in to make it look nice. And I proceeded to work through these resistors to try to get the proper, yes, time consuming. One in, one out, one in, one out, one in, one out. This went back and forth for all of these resistors until I found I didn't have what I needed, which was about 51 and a half. So I wound up putting in actually 52. I come up with a 51 and a half by using two. I believe it was a 30K and a 22K, and came out to 51 and a half. So I put that in and got the meter working. So yes, I did get it working. This is going to be a backup meter for me. Like I said, it's going to be kept in the glove compartment of the car in case I need a meter. It takes two batteries. One is a 15 volt. Takes one of these, which I think they're called unobtainium at this point, or they're worth more than the value of the meter. And it also takes a small 1.5 volt. Okay. So as long as I'm on, I'm only going to be using this for continuity checking, so it doesn't really matter. The 1.5 volt was for the low ranges. So it works. It works. And I've got this will work up to, I don't have 300 volts DC, but it's within the calibration standard of what they were talking about. I remember what the AC is. I don't remember what DC is, but AC was 4% of full scale. So at 300 volt full scale, if you're on that scale, 4% of that is 12 volts. So if you're at 125 volts, it's only good for within 4% of that. So again, if you got tiny eyes, you can actually see the markings on here. But the meter's working, and I'm happy with it the way it is. And this, like I said, this is like a backup meter for me. This top, and I'm going to show you what that's for. But let me show you the leads. Those crumpled up leads, I went out, I got some hookup wire, and I redid the cables, redid the jackets on them, nice plugs, came out good. All right, so that being said, here's a 310 that I've had for quite a while. This 310 You could actually do, I believe it's 1200 volts. Yeah, which that'll never happen. But again, it's a 310. They're both supposed to be type 3s, and they look... Yeah, hold on a second. Let me pause it. Okay, here they are side by side. Makes it easier if I'm not holding them. You can see that down here, it's a direct reading. Well, it's not really direct, but this is where you would read the AC amps. Okay. On this scale here, you use that scale, but it's not direct, you could say. It's got to be calculated in. Again, two nice meters. This clamp meter will fit on top of this one as well. It just goes in and clamps on. So that's awesome. And again, they're both type 3s. I like this. This is a meter that I use around the shop, around the desk. It's easy to handle. It's portable. It's handheld. It's nice. I don't believe it's as accurate as my DVM or my Simpson meter, but if I'm measuring 120 volts, I know if I've got 120 volts. If I'm measuring 12 volts, hey, if it's any close to 12, it's probably 12. So accuracy, it is what it is, but I think you kind of get the idea. But it is working. Just wanted to drop that in because I did it on an unboxing and said I was going to restore it. So there you go. Interesting, on this one, this is on the outside, and on this one, this lever is actually underneath this clear plastic. Here it's on the outside. There are so many variations to this. I could get into it on the schematics. This is actually a schematic for a Type 2, and it shows a full bridge rectifier. The schematic I found for the Type 3 on the bridge is 2 diodes and 2 resistors. Okay. Again, same meter, but different. All right. Thanks for dropping in. I appreciate it. Looking forward, make some comments, and looking forward to responding to you guys. Hey, click like, huh? Subscribe. Give me a break.